Hello guys and welcome back to my channel Firewall again. In previous video we have seen what is hide NAT. What we have seen what is NAT, why we use NAT, and we saw what is hide NAT in checkpoint world. So let's recall why we choose the hide NAT address. Why we hide the IP addresses, what is uh, purpose of it. So the hide address is the address behind which a network address range or a node is hidden. So it is possible to hide behind either the interface or the gateway or a specific IP address, and that purpose we use hide NAT. So this is your gateway, for example, and this is your internal network. So this all network will hide behind this gateway IP address, right? So choosing a fixed public IP address is a good opinion if you want to hide the address of the security gateway. However, it means you have to use an extra publicly routable IP addresses. Choosing to hide behind the address of the gateway is good option for administrative purpose. For example, if the external IP address of the gateway changes, there is no need to change the NAT setting. So that is what the purpose of the hide NAT. In this video, we are going to see what is static NAT, right? So let's jump back to the uh, WordPad and see how it is. So static NAT. A static translation is assigned to a server that need to be addressed directly from the outside security gateway. The packet is typically initiated from a host outside the firewall. When the client initiates traffic to the static NAT address, the destination of the packet is translated. So, how it works? Let's consider a simple diagram for the static NAT. So, consider this is your gateway, and the packet is coming like your this direction. This is the outside world, okay, and from this outside world, the packet will come. So, packet will be having a form like a IP port, then source IP, destination IP, right? So whenever the packet will come from the outside world, the IP will be the public IP address. So take any public IP address here for now. And the destination is your internal IP address. If it going, if it trying to reach to your internal IP address, so consider any internal IP address here. Okay. So what are the stages involved? So as we see in a hide NAT, there are mnemonics which come into the play, which is big I, small o, big O. In this process also the same thing will happen. So consider when this packet hit to the interface, the small I comes. When it crosses to the interface, the big I comes. When it done with the netting, small O comes, and when it go to the TCP/IP stack, then big I comes, right? And likewise, the packet state get changed. Once packet processed by the firewall, the source look like uh, say 65 1.11.1 and destination will be look like 10.1.1.101 as this destination IP address is also get translated from the whatever the IP address you have here. So this IP address most probably is a public IP address, but as a destination IP address, uh, usually when we configure the firewalls as a static NAT, whenever we hit to the firewall, we configure that IP address as a public IP address, and that need to be hit to the internal IP address. So that translation will occur. So this is how it works. So let me give you the packet stages, uh, at which stage what happens. So consider the same scenario here. There is original packet and reply packet. So first is original packet. Number one, the packet from the outside the gateway arrives at the inbound interface, as we see, which denotes small I, destined for the web server or whatever the server which are hosted internally, and it passes the security policies and the NAT rules. So consider 651.1.1 is your destination IP address, and it's hitting to your internal or one of the public IP address what we have. I'm just giving this an example. Okay, and then this get translated to your actual internal IP address, okay, which is your web server IP address. So this is uh, what the process will take place. And once the packet hit to your gateway, you will see small I notification in your troubleshooting. If packet is accepted, the packet information is added to the connection table, and the destination is translated to the post inside of the interface. So once the firewall accept this packet, the packet security rule checks happens, uh, the policy imposed, NAT rule get imposed, and once that everything is verified, uh, then destination is translated, that IP address for which we have as a destination. This is get translated uh, on the post side of the interface, which we see as I before it's routed. So still this stage, the routing is not happen, and now the packet arrives at the TCP IP stack of the gateway and is routed to the outbound interface. So once this policy imposement, like a security policy, NAT policies, everything got imposed, then packet is get routed, and you will see small o, packet is get routed, and you will see small o to the TCP IP stack or the outbound interface, and then the packet is then forwarded to the kernel side of the firewall, and you will see big O, and routed to the web server. So whichever the web server you have attached here, the packet reach to there, right? This is how happens when the packet comes from the outside world to the internal network, right? This is, we call it as the original packet. And how the reply will take place? So the reply will be from your say web servers, which we have here. So web server replies and hit the inbound interface. Then you will see a small I of the gateway. The packet is passed by the policy since it's found the connection table as we deliver all this stage when the original packet comes, and arrives at the post inside of the kernel. Then you will see big I. The packet arrives at the TCP/IP stack of the gateway and is routed to the outbound interface. Then you will see small o, and the packet goes through the outbound interface and is translated to the static NAT IP address as it leaves the security gateway. You will see big O. So the IP translation is like that. Here you will see this IP address, which is your uh, private IP address. Then uh, the policy imposement and everything get uh, uh, take place, and here the packet uh, translated to whatever the uh, public IP address you have, and then it goes to the outside world, right? So when the external server must when the external server must distinguish between the client based on their IP address, hide NAT cannot be used because all clients share the same IP address under the hide NAT. To allow connection from the external network to the internal network, only static NAT is in use. So this is very important thing when you talk about the difference between the hide NAT and the static NAT. So hide NAT mostly we use when you have a requirement to travel to the internet or make a travel of your internal servers, whatever you have, to the internet to get the access. So that time you will use hide NAT, okay? And here you have a choice giving one IP address or a multiple IP address. But in a certain requirements where uh, something from the outside world need to be access your internal network, and the access should be one-to-one mapping. So say there is a one PC, he want to access your one web server. So in this scenario, this PC will hit to your internal your public IP address. It get translated to the internal IP address and get your web server access. So this is a one-to-one scenario. Here you only have to use static. The hide NAT will not use here because we will only providing the mapping from one-to-one IP addresses. That is what the scenario. So hide NAT cannot be used because all clients share the same IP addresses under the hide NAT. So when you define one interface or one IP address takes uh, this web server to go out. So when the return packet will come, or maybe in this scenario, when this user want to access this web server, if we hit this interface IP address or IP address which we define as a hide NAT, because all these web servers are using the same IP addresses to go out, how it distinguish between the which web server is it need to be go. Because of that, this hide NAT not used for external to the internal communication. We only have to use static NAT, right?